Hello everyone. Today I will make another video for our friends old and new synchronous, and we will see how important it is the diode in the multimeter and how we measure diodes and rectifier bridges. Let's say a few things about the diode. I personally use it a lot. I measure with it diodes, MOSFET, transistor, IGBT, everything, and I understand their indications for the component problem. Basically, the diode tester applies a voltage across the components and measures the voltage drop across the components. So in a diode, when we correctly multiply it, it will show us the voltage drop across the diode. Usually it ranges between 0.3 and 0.6 volts. The diode meter, as soon as it shows us 0.600, means that we have a voltage drop of 0.6 volts. Depending on the material the diode is made of, it also shows us the voltage. That is, there are also resistors and germanium diode. And as I told you at the beginning, it is very important to know how to measure a diode, because all components are made from diodes. And if we know their structure, we can measure from transistor, IGBT, and even integrated circuits. How is the diode internally? It consists of the anode and descent. The wind is the PA and the descent is N. Good. And of course, when we say the many forms, we mean pi to go polymer and then the negative. In the red and in the N black, like that. Because like I told you, you would apply a trend above at the entrance and will measure it at the second voltage. The trend that will be applied will be the trend that will be applied. In red the sign-in and black the splin. That's why we're going to multiply it properly. Black here and the red here. So let's make her black so she won't. We get confused like this. Sync corrected by Elderman. Elderman to propagate correctly. So here we go. We see here we've multiplied it correctly. Collects 0.51, 511, so it is. 0.51 a ride here. We have a voltage drop, so it's right from 300 to 600. It's okay. And backwards, it should show us nothing. You see here I've multiplied it now. Reverse shows nothing, so 2. Here we are correct. Similar readings should also be shown on the circuit. The 2 here, so if we have a clue over 600 or less than 300, we're doing a little digging, so we can get it out, in this case, to measure outside the circuit, because there may be some other exits at the same time. Show us this indication, but it may also have a problem. We always find ways count requests first above in the circuit, like this, to not need to unstick the entire place to measure it. So let's go to the bridge, rectification. It's this chip right here, like this. I'll draw you now what it's like inside, the structure, the upright bridge. For those who do not know, the bridge is a bridge, the accessory when we apply it. Alternate voltage, it takes us constantly in the other holds. Here he takes the alternate, like this. As I show it here, the two such symbols has on, and so is supplement, which is what? The plus comes out here down at the corridor descents. Like this, pay attention to this thing. From here we get the positive trend, and we take it from the rise diodes. Many are confused with this system over here, as is the structure, and not can be measured by diodes, the upright bridge. Many have told me, that I have been told by many people, the positive, we take it from the rise of the diode, while it is not, like this. Always the positive, we take it from the bottom of the diode. I'll draw here how it is above. On the chip, the alternating top and bottom, there, I will put them here too. There you go. That's exactly how its little feet are. And now we will start taking the measurements, one by one of the diodes with resistors. Since in each diode we also have a little foot, you see here how their structure is inside the chip. We can multiply one by one the diode and see if they are correct. With multimeters, let's see it in practice. So the first measurement we can make is on the plus here and between the two alternates, where on the plus we will place the red probe, like this, as shown here, and in the alternating, we will put the black terminal so that our diodes follow correctly. So let's start. You see here, I put in the plus, the red, and in the first alternating the black, like this, plus here, and we have the first hour indication, 515 like this, 0515 is 05 volts. After we make the adjustment, we wind the coil as it is, and we move to the second alternating. With the black one, always like this, and we see the other indication, which is again the same. So corridor and left should be, we have this indication right here, 0 to 5 volts, with the red bridge, and the indication what we're going to do will be the reverse. Put the black receiver in plus, bridge, and measure the two alternates with the receiver red. You see here, peel correctly tolls, and we do. And in practice, like this, the black one here, and here we go. The red accessory to the first switcher will get us out 5 and 18 and other. Same, 0525, like this, 51 and 52 volts, 051 and 052 volts. So in this case, the divergence, the bridge, it is correct, like this. Any other's indication is incorrect. On the bridges short term, they show 0. And of course, when multiplied, reverse should not show anything like this. Let's go see it in practice. Replicate it in reverse. Look at this. You can see that it doesn't have one, no indication, not on one side. Neither. Reverse, like this. So this one right here is right, and of course it's not both of them that should show anything here, over here. Bracelets and too many times the passage, and they start there to secure in the groceries, like this, over here. This is usually where it branches off. Another final measurement we can take is in the rinse and in the together, over here. If we multiply it correctly, you see how it multiplies correctly, with the black in the together and the red in the rinse. We count 2 passages in a row, and from the other side, 2 passages, so all together parallel, 2 in a row, 2 and 2, and then parallel. So we expect around 800 to show us over there. When multiplied correctly, we said, with the unscented comparator red in the wash. And we have this indication here. $890 puts us over here. Well, any other indication we said shows us the odometer. You have a fault in the odometer. If you switch to my channel, you will see that I have made videos and measurements transistor, MOSFET, even of integrated circuits, with the help of a multimeter only, and simply looking at the block diagram, the structure of the components. In the next video, I will show you about transistors, how easy it is to measure them with the multimeter. If you liked the video, we share so that more people can see it and so that the next video goes well. Hello everyone.